Welcome to page 3 of your distributive packet. Let's take a look at some situations where we might use expanded form, factor form, and standard form. In the area provided, draw a nice equilateral triangle. All three sides should be congruent. Label the base 2x plus 4. Well, we know if the bottom is 2x plus 4, the right side is the same and the left side is the same. If we would like to represent the perimeter or express the perimeter in the following forms, we're going to start by taking the three quantities and adding them up. So in expanded form, we would write 2x plus 4 plus 2x plus 4 plus 2x plus 4. It's a lot of work to write it in expanded form. So we can write it in factor form a little bit more quickly. We have three quantities being repeatedly added together. So in factor form, we could write 3 times the quantity 2x plus 4. That's another way to express that perimeter. And lastly, we can express the perimeter in standard form. We're going to distribute that 3 and triple each of those terms. 3 times 2 makes 6x, and 3 times a gain of 4, or positive 4, gives us a positive 12. We've expressed the perimeter of that equilateral triangle in expanded form, factor form, and standard form. Let's take a look at another figure. For number 2, let's draw a perfect square. We know in a square, all 4 sides are congruent. If we say the length of the right side is 3x minus 5, that means each of the other sides can be represented with that expression. If we need to express the perimeter in expanded form, that means we need to take 3x minus 5 and add it 4 times, plus 3x minus 5 plus 3x minus 5 plus 3x minus 5. Sometimes expanded form can be a lot of work, but you can take the same expression and write it in factor form as a multiplication problem. Since we have that quantity taken 4 times, we could write it as 4 times the quantity 3x minus 5. We know that repeated addition can be represented as multiplication. And lastly, we can take factor form, multiply, and then write it in standard form. Let's distribute the 4. Using our arrows, we're going to multiply and quadruple each of those terms. 4 times 3 is 12x. 4 times negative 5 is a loss of 20, or minus 20. So in standard form, that perimeter is 12x minus 20. One more together. Let's take a look at number 3. For number 3, please draw a regular pentagon. A pentagon is a polygon with 5 sides, and a regular pentagon is a polygon where all 5 sides are congruent. So take a moment and draw a regular pentagon. 5 sides, 5 angles. Let's make the first side x minus 5. That expresses the length of this side. Well, if that's x minus 5, so are each of the other sides. If we wanted to represent the perimeter around this pentagon in expanded form, we're going to write x minus 5 plus x minus 5. We're going to have to take this quantity 5 times. That's a lot of work, but expand it out on the given line. It is repeated addition of the quantity x minus 5. That's the perimeter in expanded form. But we can write this as a multiplication problem or factor form. We have the quantity x minus 5 taken 5 times. So we can write 5 times the quantity x minus 5. We can even put a 1 in front of that x. That's written in factor form or as a multiplication problem. To finish up, let's take and multiply each term by 5. We're going to distribute that 5 to each term. 5 times 1 gives us 5 x's, and 5 times a loss of 5, or negative 5, gives us a negative 25. That's the perimeter represented in standard form. This concludes page 3 of your notes. Make sure you have all the information down. Pause the video and go back if you need to.